Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to make a tax-deductible donation to support our students, please go to smarturl.it/help ISU actuary. Here's a problem for today for exam FM in financial mathematics. A loan of $125,000 will be repaid by payments at the end of each year over 30 years. So this is a typo, my apologies. So a loan of $125,000 will be repaid by payments at the end of each year over 30 years. Payments for a given year are level and are 2% greater than those for the previous year. The monthly payment for the first year is P. The effective annual interest rate is 5%. Calculate P. And here's the solution. So the loan initial value is equal to the present value of all future payments, which is 12 times P, A angle 1, upper 12 at 5%. That's the first year worth of payments. Monthly payment is P, annual rate of payment is 12P. The payments are monthly over 1 year. Then the second year, the payment goes up to 1.02 P. There's 12 of them. The payments come over the second year, so in relation to the first year, they're deferred by 1 year. We represent this by 1.05 to a negative 1, and then times A angle 1 at 5% upper 12. And the same way up to the 30th payment, which is deferred by 29 years, or 12 series of payments, and that will be 12 times 1.02 to the 29 times P times 1.05 to the negative 29 times A angle 1, 5% upper 12. We're looking for P. P is going to be 125,000 divided by 12 angle 1 upper 12 at 5% plus 12 times 1.02 times 1.05 to a negative 1 times A angle 1 upper 12 at 5%, so on up to the last term, which is 12 times 1.02 to the 29 times 1.05 to negative 29 times A angle 1 upper 12 at 5%. We factor out 12 and A angle 1 upper 12 at 5% in the denominator. And what's left inside is 1 plus 1.02 over 1.05 plus 1.02 over 1.05 to the squared to the second power plus and so on up to 1.02 over 1.05 to the 29th. This is a partial sum of a geometric series, and so it's of the form 1 plus r plus r squared up to r to the n minus 1. So it's equal to 1 minus n, r to the nth over 1 minus r. So in this case, 1 minus 1.02 over 1.05 to the 30th over 1 minus 1.02 over 1.05. And we need to write this A angle 1 upper 12 at 5% in terms of known quantities. Well, it's always 1 minus v to the nth over I upper 12. I upper 12 is equal to 12 times 1.05 to the 1/12 minus 1. Because I upper 12 over 12 plus 1 to the 12 is equal to 1.05, where 5% is the effective annual rate. And of course you see that the 12s cancel. We can disregard them. And then everything else we just calculate. And the whole expression 125,000 divided by all of these things in the denominator, if you calculate it, this ends up being approximately 526.02, which is answer B. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.